Good afternoon, everyone. Hope I'm audible.
Good
Good
afternoon,
afternoon.
sir.
Okay. Let me share my screen. So, if you remember, I have discussed few problems and then multiplication rule for two events A and B. Am I right?
Yes, sir.
Okay. So, I have discussed about. I have actually discussed few problems, and then I discussed multiplication rule. I discussed about multiplication. Well, actually, I started. I haven't discussed much about this. The generalization of this I have not discussed. So multiplication rule for probability of A intersection B. 1 minute. Let me receive a call. Okay, so multiplication rule for probability of A intersection B, and that was defined as probability of A intersection B equal to probability of A. If you remember, probability of A given B into probability of B, or if in this expression B is known, the event B is known, you may have it like A intersection B equal to probability of B given A into probability of A. So these are the two expressions for multiplication rule. Clear? From where it is coming? It is coming from that conditional conditional probability that I have discussed, and I have also discussed some problem related to that. So if you have, this is for two events, A and B. A and B are two events. What if I have three events? So for three events, let me generalize this for three events, A, comma B, and, or let it be, suppose A1, A2, and A3. These are three events. Then the multiplication rule will be probability of A1 intersection A2 intersection A3 equal to, suppose I am considering that A1 intersection A2 I am taking together, like probability of A1 intersection A2. I am taking these two events together and then intersection A3. So can I use this, if you consider this as 1, this as 1? Can you use this?
Yes, sir.
So you can rewrite it as probability of, suppose this A1 intersection A2 is known. So this is A3 given A1 intersection A2 into probability of this is given. I am considering that this is given A1 intersection A2. So this you can write as probability of A1 intersection A2. Fine. Next, you can see that here we have two events, A1 and A2. So again, you can rewrite this as, let me write this first term as it is, A1 intersection A2, and then you can again use this multiplication rule for two events. So this can be written as probability of A1, sorry, A2 given, I'm considering A1 is given, into probability of A1. If I rearrange it, I can just, I'm writing the first, this one, probability of A into the middle one, that is probability of A2 given A1 into probability of A3 given A1 intersection A2. So what you can see, general form is there, like probability of A1, then probability of A2 given this A1 into probability of A3, and given what is given, A1 intersection A2. Both of these events are given, A1 intersection A2. So similarly, you can generalize this for any number of events. Suppose you have 4 events, you have 5 events, you have more number of events. You can easily generalize it. So let me uh, go to one problem. Let's discuss one problem. Okay, so I have written up to this first part of this. So let me read this one once and it will make some sense. So an electronic store, this is an electronic store, sells 3 different brands of DVD players. So any electronic store is selling 3 types of 3 DVD brands, DVDs of 3 brands. Of its DVD players sales, 50% are brand 1. So 50% they sell brand 1 product, 30% the store is selling brand 2 product, and 20% of brand 3. Each manufacturer offers a 1-year warranty. So 1-year warranty is for all these 3 brands, brand 1, brand 2, brand 3, and warranty on parts and labor. Okay. It is known that 25% brand 1 DVD players require warranty repair. So the first is actually the least expensive. You can see this one, least expensive means सस्ता है इसलिए ज्यादा लोग खरीद रहे हैं, 50% लोग इसको खरीद रहे हैं. बट प्रॉब्लम क्या है कि ज्यादा amount of DVDs, 25% of such DVDs of brand 1 need repair work, warranty repair, whereas the corresponding percentage for brand 2 and 3 are 20% and 30%. So problem is, what is the probability that a randomly selected purchaser has bought a brand 1 DVD player that will need repair while under warranty? This is the first problem. I am adding one more. What is the probability? What is the probability that a randomly selected purchaser that randomly selected purchaser has a DVD player that will need repair while under warranty. That will need repair while under warranty. There is third part of this problem, but I'll go to that next. Let me go to the solution of these two first. Okay. So what is given there? You can see, suppose I am considering that AI denotes that this is a brand I product. So brand I product is purchased. Brand I is brand I DVD is purchased. I may be 1, 2, 3. Why? Because there are three different brands of DVD players. You can see in the problem. So what is the probability of A1? Can you tell me? 50% are brand 1. So
1
what
by
is
2.
0.5? What is the probability of A2? It's 30% are brand 2 and 20% brand 3. So this is 0.34. Probability of A2 is 0.3. Probability of A3 is 0.2. Now, the second scenario is that these DVD players, these brands are actually giving one data, that is 25% brand 1 DVD player required warranty, whereas 20% of brand 2 and 10% of brand 3 DVDs actually require uh, repair. So let me consider once a brand of DVD, once a brand of DVD player, once a brand DVD player is selected, DVD player is selected. The second stage that we can see is the uh, thing about that warranty. Okay, the second stage involves observing whether the selected DVD involves observing whether the selected DVD player needs warranty repair. Needs warranty repairs. So I can consider that this I may consider as B denotes that need repair, the DVD need repair, and I'm considering that VDS is an event denoting no repair needed or does not need repair. So these are the two events. Once you know the player is selected, the DVD player is selected from some brand. So now you can see that probability of B, given that this is of brand A, product is of brand A, and it needs repair. What is the probability? You can see from the problem that 25% brand 1 DVD. So if it is of brand 1, then 25% need repair. You already given that it is of brand 1 DVD, then 25% require repair. So this is 0.25. So this require, this need repair, and we already know that event A1 has occurred. A1 has occurred means this is of brand 1. Similarly, what is the probability of B given A2? It is given that the product, the DVD player is of brand 2, then what is the probability that it needs repair? You can see it from 20, it's 20% for brand 2 and 10% for brand 3. So this one is 0.02, and that is probability of B given this is a brand 3 product. So this is 0.1. So these are the different probabilities that we have. So we can go to the solution, but what I can tell you is something called tree diagram that will be a more useful kind of representation where you can understand the problem, what it is actually. Okay, so let me give you a tree diagram. Okay, so the tree diagram is like you are making a kind of tree with some information about your problem. So suppose I'm starting an event. So we have three brands. So this is of brand 1, this is of brand 2, and this is suppose denoting brand 3. So what is the probability that brand 1 is selected? It's 0.5%, 50%. Brand 2 is selected. What is the probability? It is PA2 equal to 0.3%, actually 30%, so it's 0.3. Brand 3 is selected, its probability is A3 equal to 0.2. Fine. Now, if we know that it is of brand 1, then there may be again two cases. What are the two cases? One case is defective, need repair. Another case is no need of repair. Got it? So if this is for brand 1, so probability, its probability, can I write in this way? Probability that it requires repair. It requires repair, and it is of brand 1. This is going to be, what is this value? 25%?
Yes, sir.
0.25. Similarly, if you consider this one, then probability, this is actually the case, no need of repair. And this probability is, if this is 0.025, so rest all others don't need, that doesn't need actually repair. So this is 0.75. So this is a scenario, I can call it as no repair needed. And this is a scenario that repair needed. Got it? Right? Then instead of back, I click the other one, home page, home button. Okay. Then again, if I go to the next, when I have brand two products, so again we can see that it has two options. One is, this is like probability of need repair, and it's a brand two product. This probability is 0.2, and this is probability of do not doesn't need a repair, but this is of brand two. This probability is 0.8, because this one is 0.2. So what is left? It's 0.8. Next, you can see for this. This is actually the scenario of repair needed. This is a scenario, no repair needed. This is probability of B, that is repair needed, and this is brand 3 product. This probability is 10%, so this is 0.1, and this one is probability of B-dash, means no need of repair, and it's a brand 3 product. This is 0.9. You can say no repair needed. Here you have repair needed. So you can understand your problem using this tree diagram. We call it as tree diagram. So let's come to the problem. The first problem is, first one is the initial, where is that? What is the probability that a randomly selected purchase has bought a brand 1 DVD player that will need a repair while under warranty? First one. What is the probability that a randomly selected purchaser has bought a brand 1 DVD? So it is known that this is a brand 1 DVD. Then has bought a brand 1 DVD player that will need repair. So it needs repair. This is needed. So what is this probability?
0.25.
0.25.
0.25. 1 minute. Let me read that problem. What is the probability that a randomly selected purchase has brought a brand 1 DVD that will need repair while under warranty? 1 minute. This is P given A1. Actually, this is a kind of AND scenario, that this is of brand 1 and need repair. So let's calculate this first. So this probability that this is of brand 1 and need, so this is given, and then this. So this probability is going to be, from here you can see this one, 0.25. We need the probability that it's a brand 1 and need repair. This is what we actually need to find in the first problem. What is the probability that a randomly selected purchaser has bought a brand 1 DVD player that will need repair while under warranty? Yes. So this is what we need to find. So this is For this, you can use that multiplication rule. This is probability of, can we write like probability of B given A1 into probability of A1, because you know A1, A2, A3 are given. So you need to write in such a way that this can be used. A1, probability of A1 can be used. So this is going to be, this is 0.25 into this probability of A1 is 0.5. So this probability is going to be 0.125. The second problem is, second one is, what is the probability that a randomly selected purchaser has a DVD player, DVD player, anyone, first, second, or third, that will need repair while under warranty. So there may be three cases, like you need the probability that you actually need this probability of B, or let me rewrite this probability of B. Those products which need actually repair. So this may be the scenario that this is a brand one product and repair and need repair. This is the first scenario. Or it may be of brand 2 DVD and need repair. Or the third scenario may be it's a brand 3 product, brand 3 and need repair. So these are the three scenarios that you have. So you can rewrite this as probability of, or is there, so you can add the probabilities, and these are actually brand 1 and repair, brand 2 and brand 3, or all three are actually independent one. So what you can do, you can write it as probability of brand 1. So this is A1 and repair means B, plus probability of A2 and B, plus probability of A3 and B. So you can calculate for each of these by using the same idea what I have used here, this one. So the first one will be this one, 0.125, the same what I have obtained here. The second one will be A2. So this is probability of B given A2, 0.2 into 0.3. So 0.2 into 0.3, this is 0.06. Or should I write? Let me write once. So this is 0.2 into 0.3 plus this is 0.1 into 0.2, this one and this one. So 0.1 into 0.2. You can calculate this value as 0.125 plus this is 0.06 plus 0.02. You can add them all. This will be 4628.
205.
0.205. This is the problem. Got it? There is third part of this. I am giving you the third part also. Let me go to the next slide. The third part of this problem is, if a customer returns to the store, if a customer returns to the store with a DVD player that need warranty repair, that need warranty repair work, then what is the probability? What is the probability that it is a brand one DVD player? It is a brand one DVD player. First question is this. Second one, a brand two DVD player. A brand two DVD player. This is the second part. And brand 3 DVD player. This is the third part. So this problem has three parts. The first one is what is the probability if a customer returns to the store with DVD player that need warranty. So we know that it need warranty. So we are given probability one minute. What is the so for first one that will be A. So probability that it is a brand one. Probability what is given? It is given that warranty repair work needed. So this is B is given. Probability B is given. Then it's a brand one product. This is what is actually needed in the first part of this part. Second part is probability. It is already given that this needs repair from this line. DVD player that needs repair work, and it is a brand 2 DVD. It's A2. And C part is probability that it's a brand 3 and given that it needs repair. So these three things you need to calculate. What is the probability? You can rewrite, you can use that conditional probability. So this is A1 intersection B by probability of B. This is probability of A2 intersection B by probability of B, and this is probability of A3 intersection B by probability of B. So you already know from the problem that how much percent need repair. It's given that where it is corresponding percentage brand 2 and 3 respectively. So what is the PV value?
0.205.
0.205 we have calculated somewhere. Yes, we have already calculated in the previous one. So this is 0.205. And what is this value that we have also calculated? 125.
0.125.
125. This is
Yes,
0.61 or something.
609.
609. I'm getting it. This one is already known. That's 0.06, I think. This by PV is known 0.205. So this is going to be 0.29. This part, this one is either you can use the same that I have used for this one. I have used that value as 0.0, 0.020 by 0.205, some value. Or what you can do 1 minus these two. Can we do like this also? So this will be 1 minus 0.61 minus 0.29. This value is 916289. How much? 0.10.
Yes, sir.
If you use this one here, this should be same 0.10. So this is how you can calculate these values by using the conditional probability. So next we will see something that actually separates the entire statistics in two parts. That is called Bayes theorem. Only because of this theorem, Bayes theorem, the entire estimation theory in statistics is divided in two parts. One is called classical estimation and another one is called Bayesian estimation. So you can understand that how powerful this Bayes theorem is actually. So this is very, very powerful theorem. This is widely used in estimation theory. Okay. This is Bayes theorem. What is the basic idea why this is so much used? This is used because of its capability or its ability to incorporate or to involve the prior knowledge to the estimation process. So what is estimation, that we will see later, but let me just tell you that if you are estimating something, some parameter, and if you can use the prior information about the parameter in your method, then this Bayes theorem is that process, that method is. So let me give you this as a probability only. Okay, so don't go so far for that estimation related things because that's a later thing. We will discuss it later about estimation. So let me tell you first the law of total probability. Okay. The law of total probability. So what is law of total probability? Let's see. Suppose you have some events A1, A2, up to AK. So you have K events which are actually be mutually exclusive. Be mutually exclusive. Mutually exclusive means disjoint events. Nothing is common between any of these two, A1 intersection A2 intersection A3 intersection AK. If you take the intersection of all of these, nothing is common. So be mutually exclusive and exhaustive events. So again, what is exhaustive event? I have already told you that if you take the union of all these, this should be the entire sample space. If you take the intersection of all of these, this is mutually exclusive. If you take union of all of these, this is This should be the entire sample space, and then we call it as these different events as exhaustive events. If the intersection is phi, it's mutually exclusive. If the union is S, it's exhaustive. Then for any other event, then for any other event B, B is any other event, and suppose that may be subset of the sample space. It is not written that how that B is defined. So what you can see that you can rewrite B using these events A1 and 2 AK as probability of B given A1 into probability of A1 plus probability of B given A2 into probability of A2. Similarly, you add it up to kth term. So it's probability of B given AK into probability of AK. So this will be B means all of these A1 and 2 AK can be used as a multiplication theorem, what we have discussed, and then we can get the entire this probability for this event probability of B. You can rewrite it as summation I equal to 1 to K probability of B, this 1, 2, 3. So I am putting it as AI into probability of AI. So this is how you can rewrite it. If you want the proof, I can give you the proof of this. Let me give you the proof also. So proof of this is like we have seen that A1 and 2 AK are mutually exclusive since A1, A2, and AK are mutually exclusive. Means there is nothing common in them. So you can take AI intersection AJ, any two, or in simple you can write it as AI AJ equal to phi for all I not equal to j, where I and j can be 1, 2, up to k. Since these are mutually exhaustive, means A1 and 2 AK are mutually exhaustive, exhaustive events. So exhaustive events means if you take the union of all of these and A1, A2, AK are mutually exhaustive or simply exhaustive, HAUSTI, exhaustive, then if you take the union of all of these A1 union A2 union A3 union AK, A1 union A2 union AK, this will be the entire sample space. Got it? Now, if I write this B as the B intersection S, can I write the event B as the B intersection S? Because S is everything. And I am taking intersection of B from everything. So that will be B only. Got it?
Yes, sir.
Okay. So what you can do, you can write it as B. Then in place of S, Can you write all of these? A1 union. Actually, you can use plus also, but let me write it as A1 union, A2 union, A3 union, AK. Now, using the third axiom of axiomatic definition, if you remember, or let me first see, let me expand this. So this is B intersection A1 union B intersection A2 union B intersection AK. Can I write like this? Distribution over this intersection. This is being distributed to each of these. And now, if you see each of these, since A1, A2, AK are mutually disjoint or mutually exclusive. So if you take these intersections, B intersection A1, B is maximum A1, then this will be A1 or less than A1. But it cannot exceed A1. Similarly, here also it cannot exceed A2, it cannot exceed AK. Actually, this implies this B intersection A1, B intersection A2 up to B intersection AK are all again mutually exclusive, are all mutually exclusive. Got it? Any question? Let me know. Hope you understood this, why I am writing that these are mutually exclusive. Well, A1, A2, AK are disjoint. Then there, if I take intersection with anything, even I take intersection with sample space, this can be A1 only, maximum, or less than A1. So again, these intersections will be having no common element, will have no common element. Okay. So these all intersections are mutually exclusive. So now you will have, like, if you take any of these B intersection AI, intersection B intersection AJ, for any, this will be B AI intersection AJ, and this will be actually uh, B intersection, this is intersection phi. So again, you will have nothing common in them. I not equal to j, where I and j can be 1, 2, up to k. Understood why I have written these all as mutually exclusive? Because of this. Got it?
Yes, sir.
Any confusion? Let me know. Now, from the third axiom of the definition of probability, if you remember the definition of probability, the third axiom is that if A1, A2, and so on are mutually disjoint events, then probability of A1 union, A2 union, so on is equal to summation of all of those probabilities. Am I right?
Yes, sir.
Now, from the third axiom of probability, you can write probability of B. Let's see this one. Okay, so probability of B equal to probability of B intersection A1 plus probability of B intersection A2 plus so on probability of B intersection A, K. Can I write like this? Again, you can apply the multiplication rule here. You can rewrite it as probability of B given A1 into probability of A1 plus probability of B given A2 into probability of A2 plus so on probability of B given AK into probability of AK. Can I write like this? This is probability of B. This is what actually I wanted to prove. You can see this one, or you can rewrite it as summation I equal to 1 to K probability of B given AI into probability of AI. So this is the proof of this total law of total probability. I will define this Bayes theorem, I think, in the next class, and I will give you some problems also. If you have any question, let me know. Anyone?
No, sir.
Anyone is copying? Done?
Yes, sir.
Okay. So 63 only. Let me take the attendance. Can I start from last today? 3425,
Present, sir.
3383, 3382,
Present, sir.
3368, 3368, 3362. Hope this is visible. This screen is visible to you.
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So there I am. 3362 present. 3346,
Present, sir.
3345,
Sir, 3368.
3362,
8.
68. Okay, done.
Sir,
3345,
3362 present.
3362
62.
present. Okay, done.
Sir,
3346,
3338. Sir, 3383.
how many students are there? Let me see. 69. How? 63 to 69 at the end. 3346, 3345, 3340,
Present, sir.
3336,
Present, sir.
3250,
Present, sir.
3242, 3237,
Present, sir.
3232,
Present, sir.
3223,
Present, sir.
3218,
Present, sir.
3213,
Present, sir.
3212,
Present, sir.
3211, 3210,
Present, sir.
3205,
Present, sir.
3203,
Present, sir.
32863,
Present, sir.
2863.
Yes, sir. Present, sir.
Okay, 2853,
Present, sir.
2823,
Present, sir.
2821,
Present, sir.
2739,
Present, sir.
2731,
Present, sir.
2725,
Present, sir.
2722,
Present, sir.
2720,
Present, sir.
2709,
Present, sir.
2683,
Present, sir.
2682,
Yes, sir.
2679,
Present, sir.
2677,
Present, sir.
2673,
Present, sir.
2669,
Present, sir.
2649, 2637,
Present, sir.
2617,
Present, sir.
2605,
Present, sir.
2461,
Present, sir.
2446,
Present, sir.
411, 2406,
Present, sir.
2246,
Present, sir.
2040,
Present, sir.
2039,
Present, sir.
2016,
Present, sir.
1970,
Present, sir.
1864,
Sir,
185.
1855 present.
Okay.
sir.
1864
present.
Okay. 1821,
Present, sir.
1799, 1792, 1746, 1746, 1617,
Present, sir.
1599,
Sir, he is present.
Got disconnected.
1598,
Sir, present.
1596,
Present, sir.
1581,
Present, sir.
1565,
Present, sir.
1561,
Present, sir.
1533, 1533, 1510,
Present, sir.
Present, sir. 1510 present, sir.
okay, 1274,
Present, sir.
1158, 106, 1053,
Present, sir.
768, 5768,
Present, sir.
5652,
Present, sir.
5622,
Present, sir.
5534,
Present, sir.
5308,
Present, sir.
5273, 5237,
Present, sir.
5171,
Present, sir.
5138,
Present, sir.
5007.
Present, sir.
Okay. Thank you for joining. You may leave.
Thank you, sir.
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 Okay.